We talked about making images in geometrical optics, and it was sort of this mysterious, the light hits some glass and comes back together. So now I want to show you a more physical explanation of why images form. So let's look at diffraction and image formation. So we really want to go right back to that nice little aperture that I just erased for some reason. So it was something like this, and we thought about it in an XY grid, kind of like that. And we said, okay, if the light diffracts through this aperture, we can use this grid to do this integral and everything. And we said, what kind of light pattern does that make over here at P? And we said, well, E at P was we had to take an integral, and it was the field amplitude per unit area over R, and it had E to the J omega T minus K R, and it had a dA. And we went through and did all the steps you have to do to get there. What we want to do now is think about how do we use this to make an image. What you could do is inside the aperture, imagine putting the object, right? So rather than it just being completely open to light and just adding all the Huygens wavelets evenly, imagine we had something we wanted to make an image of, like this smiley face, right? So now let's pretend everything's inverted and the smiley faces, the eyes and the mouth are black rather than white chalk, whatever. But basically, as you add up the Huygens wavelets, instead of making each one equal, all you got to do is modulate them. All right? So the Huygens wavelet up here, where there's nothing, where it's transparent, that one's strong. The one right under the eye is low. So basically what you do is EP is you replace the uniform EA over R, that's saying all of them have the same field amplitude, with the pattern of the object. All right. So what that means is then you could say EP, it'd be some integral of what we could call, just replace this whole thing with something, let's just call it E of the object. Now let's not worry about it being a spherical wave and all that kind of stuff with the R's and all that. Let's just call it E of the object, not worry about it for right now. And then that would be E times E to the J omega T minus K. I'll write big R, because I'll go ahead and remind us that we did have that phase factor figured out. It was E to the J K big X X plus big Y Y over R, and then dA. So the diffraction pattern you would get if you put an object in there and modulated those Huygens wavelets, the diffraction pattern you get on the screen would follow an equation that looks like that. So let's see what that does to the pattern.